my math analysis legacy project, and I'm going to show you how to consistently hit on a par 3. And after that beautiful intro, I'm going to show you how to consistently hit on a par 3. But first, we must show you the perfect swing to get on that par 3. So with me, I have a 7 iron, 6 iron, and my driver, which I'll be showing you in the videos coming up. And so with every par 3, you must have the perfect swing, like so. And in the video coming up, I'll show you exactly how to do that.
This diagram of a golf swing basically shows the fundamentals you'll need to reach a par 3 green. We have R, which is the radius of the golf swing, P, the grip of the golf club, G, the center of the mass of the golf club, L sub G, which is the length of the golf club, which is the distance from P to the center of mass of the golf club, theta, which is the angle the golfer is swinging, and the fish or the angular acceleration sign, which will be used to calculate the angle used to show the angle of the golfer's arm. The next diagram is of the golf club itself. What you need to know is that the diagram is of G parentheses XY, which is the center of mass for X and Y. Each of the equations shown are used to express the position of the center of mass. So the prior two photos, which I talked about, basically show what your center of mass should be when you're swinging at the ball. The equations shown, which you could use to calculate these, are x equals negative r sine times a theta plus the length sub g times cosine parentheses theta plus angular acceleration minus 90. And basically, as you can see, it goes on for depends on which area and which angle you're pointing at for the golf swing, and that's how you get the other equations. Next, we'll use Newton's second law, which is the general force equation, which is sigma F of y equals mass times acceleration due to the center of mass sub the x direction, which the sigma of f of x or f of y is the sum of the forces in the x direction. Mass is the mass equals of the golf club, and the acceleration sub g of x is acceleration of the center of mass in the x direction, all of course respect to the ground. The general moment equation for rotation of the rigid body about the center of mass is g, and that equation is the sigma of the moments due to the center of the mass equals the inertia sub g times angular acceleration of the club. And what that means is the sigma of m sub g is the sum of the moments about center of mass. The inertia sub g is the moment of inertia of the golf club about its center of mass, and the angular acceleration is the angular acceleration of the club. After using both of those equations, we'll end up with this resulting equation. Negative radius times sine of theta times theta squared times the mass times the length of the center of mass of gravity times cosine of an angle plus angular acceleration minus mass times gravity of L sub g times sine of a theta plus angular acceleration plus radius of cosine of theta times theta squared times mass times length of sub g times sine times theta plus angular acceleration, and that will equal length of the center of mass of the club squared times mass plus the inertia of the center of mass all times by the center final angular velocity and acceleration. So practically, after looking at all those equations, all we really need is that last equation we just talked about, and this will solve the swing where the wrists are uncocked, which are the shots we'll be looking at today. And that's the perfect swing you'll need to hit on a par 3. Now let's head out to the course.
Now that I taught you about the perfect golf swing,
hey Ian, look at this.
Oh man, I think you missed the green right.
Yep, I missed it.
It's alright. I'll show you how it's done. See that? And in this video, I'll show you exactly how to hit on the green. The holes we'll be looking at today are hole 2, hole 6, and hole 17. The reason I chose these holes are because it covers the what ifs, which are the yard/distance, the depth/height, and the force to make it onto the green. I calculated my swing speed with each club by dividing the distance of my club with the time of my swing, which is about 39.8 meters per second with my 7 iron, 40.7 meters per second with my 6 iron, and 46 meters per second with my driver. To calculate the force needed for each hit, you need the potential energy formula, which is mass times gravity times height, and the kinetic energy formula, which is 1/2 times mass times velocity squared. With the 7 iron, my potential energy is 818.921 joules, and my kinetic energy is 43,830.38 joules. My potential energy with my 6 iron is 818.921 joules, and my kinetic energy is 45,835.7 joules. My potential energy with my driver is 818.921 joules, and my kinetic energy is 58,548.72 joules. With this amount of energy on each hole, I will be able to reach the green. With these equations, you will be able to find out the force and direction you'll need to hit on any hole, which covers the infinitely many par 3s. It's nighttime. I'd just like to thank you all for taking your time to watch my video on how to hit consistently onto a par 3.